Hello and welcome to our seventh meeting of CKAD study group. This is our final, last one meeting regarding preparation for Certified Kubernetes Administrator Application Developer exam. I hope so far you liked it. And before we move on, for people that are for the first time here, let me quickly introduce myself. So my name is Łukasz Tomaszkiewicz, but you can call me Luke Thomas. It's easier to speak, especially if you are a foreigner, not the Polish person. And I help developers and DevOps engineers to accelerate their career in the cloud. You may ask, how do I do it? In a couple of ways. For example, I run YouTube channels, Luktom devoted to the leading infrastructure provisioning tool called Terraform. And also second is a path of AWS developer, in which I teach how to develop software that can use all the capabilities of the cloud. I recently created a nice landing page for that second course, so check it out. If you are a Polish speaker, then it may be interesting for you. I also run on-site workshops, so if you or your company wants to have any kind of training related to the Kubernetes, to cloud or something else, then just contact me and then we can arrange some kind of workshop. And finally, I'm currently employed at AWS as Senior Cloud Infrastructure Architect, and I mainly focus on the serverless projects right now. So far we've got a couple of meetings and we covered most of the areas of CKAD exam, and today is our last meeting and it will be devoted for services and networking. And I hope you have your exam date already booked, already scheduled, and I hope that this course helped you with preparation for the exam. So today our last topic is, and our last domain of the exam is services and networking, and there are a couple of topics we want to cover over here. So basically, first one is network policies. We will cover what are the network policies, how can we use them, and a couple of tips related to that. Then we've got a topic about troubleshooting and exposing your deployments using the services. We will actually recap what I already told in one of the previous meeting, because we already talked both about the services, which is the topic for today, as well as ingresses. However, today we will dive deep and I will show you a couple of things so you can see how to troubleshoot them in practice. So a first topic is demonstrate basic understanding of network policies. So what are the network policies? Basically, it's kind of firewall, I can say, that allows you to filter the traffic between the pods. And it's really important that it's targeted for the pods. You have no capabilities, for example, for setting up the rules for nodes as well as other stuff like services. It's strictly about the traffic between the pods. And basically, the implementation of that network policies is pushed back to the something called network plugin, container network interface in the terms of Kubernetes. So before you use the network policies, you need to make sure that you are using a container network interface that is actually providing that feature. For example, you can use things like Weave, like Calico, like KubeRouter, if I remember correctly. These are the network plugins that support that. On the other hand, for example, you can also include things like Calico policy extension for AWS CNI networks. This is, when you are dealing with Kubernetes cluster in AWS cloud. So make sure that you have that enabled in order to make network policies to run. Also, when you are dealing with AWS cloud, make sure that there is no collisions with security groups. In AWS, it's possible to use both. I mean, you can both enable network policies on Kubernetes level, as well as you can, by using an integration with VPC, enable security groups which work at the VPC level. So depending on your use case, one may be better than another. Using network policies, we are able to filter both ingress and egress traffic, so both incoming and outgoing connections. But there are exceptions. We are not able to filter everything. For example, we are not able to filter out the traffic that comes from the node the pod is running. And then there are also a couple of other exceptions. However, I'm not going to dive deep. And they are additive. What does it mean? It means if you have multiple network policies which target the same pod, and they are basically combined using OR operator. So if any of the network policies allows some kind of traffic, it's allowed for that pod. And we've got the question, can we remove and replace already configured CNI plugin with another? Yes, we can. It's actually perfectly possible. On my very, very old blog, 3 years ago, I wrote an article about that. So this is about replacing a native AWS CNI plugin with Calico, the full-blown Calico. I mean, you may wonder if it's really needed. There are a couple of use cases like development and limitation of the IP of the pod's EKS. I don't want to dive deep on that. However, it's perfectly possible. You can just remove the AWS CNI and then add Calico components, and this way you've got another CNI. Of course, it's possible also to replace that with other kind of CNIs. However, I like Calico. It's quite nice in terms of setup and monitoring. Depending on your use case, you may find it also useful for you. I also worked a lot with WeaveNet. Weave has a nice tool called Weave Scope, which allows you to some kind of insight about how your network is going and how your network on Kubernetes works. This is very similar to things that Services Mesh offers, but it's used for the typical Kubernetes clusters without Service Mesh. Yeah, so this is about it. And a final thing about network policies that you need to know is that they are allow only. So there is no possibility to actually perform the deny rule. So you cannot drop a specified kind of traffic, and you can only allow some kind of traffic. But there is a special behavior of that network policy. So basically, if there are no network policies in your cluster, then your pods are allowed for any kind of traffic. So basically, if pod does not have any network policy, then it can communicate with anyone. But if you set some kind of network policy and set targeting for a specific pod, the pod will be able only to use that traffic. So I will show the example later. You can create a dummy network policy that denies all the traffic in the cluster, and this way you have the capability of limiting the traffic for the whole cluster and then allowing only the selected traffic. But it's not possible, to drop the specified traffic, as well as it's not possible at the moment to log any traffic to some kind of journal or log file. So this is a network policy example. As you may expect, it's a typical YAML manifest that starts with API version and a kind of network policy. The metadata part is the same as always. And there are a couple of specific things under the specification block. So we've got policy types. There are two of them. And there is an ingress and egress policy type. You may specify one or other inside here, inside policy types, and the policy will apply to that specific kind of traffic. It's important to know that, they are not related one to the other. You can, for example, specify a policy for ingress traffic, and this way you will limit the ingress traffic to the pod. However, as you not specified any egress traffic policy, that egress traffic will be allowed. So make sure that you are setting the correct types of policies. Then we have a pod selector. Pod selector basically tells Kubernetes to which pod it should apply that specific network policy. So here you can specify, for example, labels and match all the pods that have a label of role equals DB. and this way it will affect only these specific nodes. After that, we've got a big block with ingress. It specifies the incoming traffic to the pod. And basically, we've got a block of here to here. We've got the block of from here. And there are a couple of different sources we can specify here. First one I've got in my example is basic IP block. Here, as you can see, we can set the networks or IP CIDR ranges and that we want to allow to connect to our pod. So basically, as you see, I'm specifying this one. However, I can do some kind of exceptions. So for example, I can exclude that one from the above specified seed range. So this is kind of elastic. You can model the incoming traffic as you wish. Then we've got a second rule called namespace selector. And when namespace selector is used like that, then we are allowing all the traffic that comes from the namespaces, which labels project my project. So basically, if you have any pod that sits in the namespace with the project my project label, then they are allowed to connect to that specific pod. And there is also the third one, which is a pod selector. It works similarly to namespace selector. However, it matches all the pods with the label, for example, frontend here, role equals frontend. So basically, we are allowing here our pods from frontend to connect to our pods with role DB. It is perfectly possible to mix the two of them, the last two of them. So basically, you can use both namespace selector and pod selector, but just remove the one. And this way, it will match on both of these conditions simultaneously. So basically, it needs to match both the namespace and pod selector if you don't use the dash here. However, if you specify them as I did right now here in my example, this is, additive. So there are three origins of traffic that are allowed here, and this is the one over there. The second one, this is the first one, this is the second one, and this is the third one. So our origin needs to match to at least one of the rules here, and it will be automatically allowed to connect to our pod. Then we have a specification of the ports on which we want to allow the traffic. And as you can see, we've got port 6379 here with the protocol TCP. This is a list of ports, so you can specify as many ports as you wish. About the ranges, I will cover that in a minute. And then, as our policy, if you remember, is both for ingress and egress, we can allow some kind of traffics that will leave our pod and to the external networks. And here we are allowing for IP block with that side range. So our pod will be allowed only to connect to all IPs with matching that condition. Of course, you can use the same syntax for namespace selectors as well as pod selectors, and they will also work just fine over there. One thing here, as you can see in the last line, there is an end port over there, and it means a range. So if you specify only the port, a single one port, it will be applied only to that port. But if you specify end port, you will create a range starting with this one port and then ending on this one. So basically, you will open 1 to 3 ports for egress traffic. So this is basically it. It's working like that. And here I've got an example of deny by default. We've got some questions, so maybe I will answer. If we inform only IP block and exclude namespace and pod name, will it be fine? Yeah, it will be perfectly fine. As I said, this is additive, so you can set, for example, this one, only the first one, or you may say I'd like to have only this one. So you may set as many as you wish. You know, everything is okay here. Whatever you need, you can specify here as a additional rules here in the from block or in the to block. So, for example, if you want to allow connection to other namespace, you can specify it here. However, one remark here: if you have two pods and one is trying to connect to the other one, you need to make sure that both this one is allowed to outgoing traffic and this one is allowed to incoming traffic. So basically both sides needs to agree that this one is allowing outgoing and this is allowing for incoming traffic. So this is it. Of course, if you do not apply some kind of network policy, as I mentioned before, to the right one, it will be allowed by default for all egress traffic. And there is a policy like that. This policy is basically denied by default. So if you apply that network policy, you know, to a specific, I mean, this is not specific one. As you can see, there is a special kind of pod selector. This is a pod selector that matches all pods. So basically, all pods that are running in the cluster will be considered when applying that network policy. And as you can see, that policy is both for ingress and egress traffic. So basically it will block all the communication in the cluster by default. And if you want to allow that, then you need to, of course, create another network policy that will just add rules that are allowed over there. So this is working like that. One thing I'd like to mention right now, let me quickly just check the thing. So just to be more precise, it will not block the all communication within the cluster, but only with the specific namespace. Here we've got no namespace defined, so it will basically block all the traffic within the default namespace. But if you specify the namespace over here, then it will block traffic in that specific namespace. If you remember, I recently talked about limit ranges and quotas and other stuff. So you may basically use also that stuff to create some kind. Oh, sorry. Actually, I didn't mention about that, but there's a nice operator. Let me quickly Google that for you because it's really useful. Of course, it's outside of the exam. However, it's super useful, I can say. Let me put it on the screen. So this is called namespace configuration operator. I think this is the one, yeah. And it's coming directly from the OpenShift from Red Hat. And what it does, basically it creates, oh, I see, they changed a couple of things. But using that namespace operator, you can create an object like that, a namespace config. Maybe let me make it bigger. And with that namespace config, you can set the label selector that will actually match your namespaces. And then in each matching namespace, it will create objects by using this template. So for example, if you are a cluster administrator and you want to restrict some things, or maybe create a resource quota as you see in this example, or maybe create a network policy that blocks all traffic by default, then you may use that namespace config object to actually apply that default objects inside your cluster. So it's super useful because you don't have to worry about, you know, and remember about creating stuff like deny by default network policy. You can use that project and install that operator and it will do all the stuff for you. Okay, we've got one comment. When defining a pod or namespace-based network policy, you use a selector to specify what traffic is allowed to and from the pods that match the selector. Yeah, I'm quite sure about it, and I think I said exactly thing like that. And regarding the network, a namespace selector, it's about other namespaces. So basically, Here I'm specifying that I want other namespaces to match that traffic. So basically, if I'm in the namespace A, then and I want to allow namespace B to connect to my namespace A, then I create a namespace selector that basically matches the traffic from other namespace. So this is about it. So it's about cross namespace communication. Yeah, so I hope that clears the confusion over there. So if you have any questions, just write them down, and if there are no questions, then I will go to the second topic here, and then we will go to the demo. Yeah, it's perfectly possible to filter between the namespaces. That's right. That's right. So basically, by default, the network policy is applied to the namespace. However, it's possible to specify that you want to allow a connection to other namespaces. If you want to, for example, forbid connections from other namespaces, then you are just creating, a policy that denies by default and matches all the pods, and then you are creating a policy that basically matches only the self namespace, I mean the namespace we are running in, and this way you will target all the pods within the namespace to connect to each other. So yeah, that's correct. So this is it. Okay, so let's go to the second topic for today, which is services. And here we will be exposing our services, our deployments with services, and basically a quick recap: what are the services? So as you remember, services is some kind of very, very simple load balancer, I can say, something that exposes your pods as a unified name and unified endpoint. So basically, instead of contacting the specific pod using the specific IP address, you can use DNS inside the cluster or outside the cluster and point to the specific service IP. And by using that service IP, Kubernetes ensures that your requests are route to all pods that are in the ready state. And this way you can both load balance the things. It's basically random. And then you've got also failover load balancing, because if one pod is not ready, or maybe it may be dead and not serving the traffic, then Kubernetes will take out that pod automatically from the service registry, from the endpoints collection, and then service will not route the traffic over there. So this is also some kind of measure of preventing measure for high availability. So by using services, you are providing a high availability endpoint for your workloads. So they also provide kind of service discovery, because some of the applications also can use services as a kind of service discovery. You can query the Kubernetes API. I will show that later. And by querying Kubernetes API, you are able to locate all the pods that are associated with the service. If you don't remember, services are associated with pods like everything else in Kubernetes, and by everything else in Kubernetes, I mean using labels. So basically, by specifying label selector, you are able to associate service with the pods. Yeah, it's also kind of abstraction over pods when it comes to networking, so you don't have to care about their specific IP addresses. And there are a couple of types of services you need to be aware of. So first one is the cluster IP. This kind of service basically creates a service that is cluster-wide, and by that I mean all pods within the cluster can contact that service, and by contacting that service, they are pointed, to the specific pod that will handle the request. Second one is called node port. When you are using a node port type of service, your service will be exposed to outside world, and it's exposed in this very specific way. Basically, each and every node in the cluster opens a port on the node and exposes that port to the external world. So whoever connects that node port will be forwarded to your pod serving the traffic. Node port is especially useful both in the cases of Kubernetes at the edge, when you usually have some kind of single device and you just want to expose some kind of services. And it's also used especially if you are using on-premises and manual configuration of some kind of load balancer. So for example, if you've got load balancer at the edge of your on-premise network and you want to point, to the specific service inside the cluster, then a load balancer can basically point to the node port, and then node port will forward that to the specific service. And then finally, we've got a type of load balancer, which is especially useful inside when you are dealing with the cloud deployments of Kubernetes, because using a load balancer can automatically provision a load balancer inside the cloud for you and configure that load balancer and set everything up so traffic just flows through the load balancer to the service. I see that we've got the question. And I will answer in a moment. Just let me explain the last type of the service. Last type is external name. It's kind of meta service. It's used especially as the abstraction layer for external resources. So for example, you've got external database, but you don't want to specify everything inside the application by using IP of that name of that service or DNS name of that service. You can specify some kind of external name service and then point that external name service to the external service. So this way you are creating some kind of not proxy but DNS record inside the cluster that will point to the outside world. Sometimes it's useful, but mainly it's kind of niche use of that. Okay, we've got a question from Arthur. Sorry, I'm still a bit confused. Can you explain how traffic flow between load balancer, service, ingress, and service? Always pods are associated with service, even in ingress. Yeah, I will show you that after in the next subject today, because last subject is a ingress subject. And I've got a couple of diagrams that will show how the traffic is flowing. So just wait for the last topic. Do you know how traffic provide load balancer on premise? Yeah. I will explain that in the ingress section. Okay, so just to recap, we've got a service manifest. Here, the service uses the selector to put and point to a specific application. Here, it's selecting all the pods that have a label of app equals Nginx. And then we've got the specification of the pods. So basically, we've got a name of the pod here. I highly recommend that you are using port names because it's less confusing for people. Then we are of course using TCP protocol, port 80 and target port 80. Target port can be a name or can be a number, and it points to the configuration of your pod. And basically, as you remember from one of the previous meetings, we can name the ports on the pod, and then we can just refer here in the service to point it by name, for example. And finally, we've got a type of the service. Here it's a cluster IP, so that means that it will be available inside the cluster, but not outside of the cluster. When it comes to troubleshooting the services, there are a couple of things that you need to check. So basically, first, you need to check if there are pods associated with the service, and basically check if that pod is running. So if nothing responds to your request when you are connecting to the service, check if there are any pods that are running and they're healthy and other stuff, and this way you can ensure that there's something that can serve for your workload. Then you need to check the labels on your pods and services. They always need to match. So basically, if you have different selector inside the service definition than you've got in your pod definition, it won't work. It will be unable to route the traffic to the correct pod. Then we need to check the endpoints. I will show you how in a minute. And also we may check network policies. One thing about network policies you need to know, they are applied, as I mentioned, to the pods, and they have nothing to do with the services, unfortunately. You cannot apply network services, network policies to services in other way than specifying IP of these services or range for all services within the Kubernetes. Unfortunately, it's kind of bad, I think, because it leaves security vulnerabilities. For example, if you allow traffic to all services within the cluster, you are basically cannot limit that to only the things you want to limit to. And finally, it's also possible that your microservice or your service inside the cluster or your container that you want to connect to the service has invalid DNS name. Every service within the cluster has a name of the service, point, name of the namespace. So if any part of that DNS name is invalid, then it's possible that your microservice will be unable to connect to that service. Okay, and we've got a question, port service port. We've got a couple of, the one port over here is the port that the service will be listening on. So basically, if you define a service like that, it will be listening on the port 80 and then forwarding to the port 80 on the port that matches the selector. So basically it is how it's working. Of course, these two ports does not have to match. You can specify different port and then route that to the different port. So this is, kind of abstraction over the specific implementation. So basically, you can change the ports on the pods and then match them here on the service. However, service can stay on the same port it used to. It listened to so far. So basically, this is a nice kind of decoupling over there. Okay, so basically, let's go to a Kubernetes cluster right now. I will show you a couple of things. Let's go to service, directly to services. We've got a couple of services over there. If you remember, this is our rolling update example. It's 13 days old. And we've got a couple of things here. Let's first examine YAML file and the YAML manifest for that service. You can see a couple of interesting things here. So first you see that there is a type of cluster IP, and by that we can make a conclusion that this is internal one. We have a port mapping of port 80 here. We've got a selector with app rolling update sample, and we can find a couple of other interesting things here. For example, we've got a cluster IP over there, and also cluster IPs that this is, just a repetition for other use cases. And by using that cluster IP, I can basically connect to that service from any pod inside my cluster. So by, simply connecting to that one, I can connect over there. I can also connect to that service using the name rolling update sample.sampleUp. So basically any service from that cluster will be able to connect to that specific service. So this is it when it comes to describing the YAML of that thing. However, if I press D here in K9S, I will go to the description. Of course, this is similar if you issue kube control, describe service and then service name. But here you've got more information about runtime. So not only you are seeing the IP and that was associated with a specific service, but you are also seeing this one. So basically this is very, very important because these service endpoints tell you two things. First, it tells you if your labels are correct. So basically if you confirm by going, for example, to pods and describing the pods, and you confirm that you've got some of the pods, they are running, they are ready, as we can see here. And if you confirm that, you can go to the service and then simply check if the labels match. So basically, in case of the labels match, you will see some kind of endpoints here. If I change the label over here, let me quickly edit that file. For example, where is my selector? I'll add invalid here. Then, sorry, something is colliding me. It doesn't allow me to do it again, as I'm using a flag over here, and it's basically messing with my changes. Let me quickly, oh yeah. And now, as you can see, I changed the selector to invalid. So at the moment, my selector and my labels on the pods does not match. Don't match. And as you can see, we don't have any endpoints defined over there. So it simply says that I've got something wrong with my labels. Let me quickly edit that service again. And if you find that kind of error, it's as simple as editing to the proper labels. And within a second or two, you will see that there are endpoints that just showed up over here. So this is the first thing, that it tells you that your services are using the correct labels. And the second thing is it shows you which endpoints are actually mapping to. So you see the IPs of that endpoints and ports on that endpoints as well. So you make sure that these all match to the desired state. So this is it. Here you can see a couple more interesting information. For example, I've got a service for traffic. Traffic is an ingress controller here. I will cover that within a minute. But you see that this type of service is a load balancer. And this is an interesting one because that means that it exposes the ports to the outside world. So basically, as you can see, I've got some kind of IP. This IP is external one. In my case, it seems like internal because, this is just an EC2 instance that is running on AWS within a VPC. And by default, it gets external IP from the private IP of that thing. However, I'm perfectly fine with, connecting to that specific instance by using their external IP, and then my traffic will just respond to that. And so this is it. In case you are using, for example, EKS, which is a managed service of Kubernetes, for testing reasons and learning, probably it makes more sense to use just the Kubernetes cluster installed on your EC2 as you are seeing it now. But for production use, of course, you should use EKS, which is, a managed service that will do just fine on the prod. And in case of EKS, you will see something different. You will see that external IP is an IP of the load balancer. So you may see also here a DNS name in case of AWS. So there's a difference like that. And here inside the ports, maybe let me quickly describe that. You see another interesting thing. Basically, we've got two ports defined. As you can see, we've got a first port over here. Here you see port web TCP port 80. This is the port that we are exposing our service to the external world. And here you see that there is also a node port specified. In case you are using a load balancer, under the hood, Kubernetes provisions a service with node port. So basically it exposes some port of the random port of the node. And then it updates the service definition. So you are seeing that actually it's exposed on that port. And this is the port that the service is actually listening. I mean, the node is actually listening. So this is working like that. And it's perfectly fine right here. Let me also show you the YAML file. Yeah, and here in YAML file, as you are seeing, we have only that port specified. There is no mention about node port. So this is, everything is doing automatically because the type here is load balancer. Yeah, so this is it. There are a couple of more advanced use cases of services which I won't cover today. For example, you can set some kind of session affinity, and then there is also a way to include the topology of the network. So, for example, if you've got a highly available cluster that spans across different availability zones, then you may set that kind of topology preference to use the local availability zone if possible. So, but these are the advanced topics, so I'm not going to cover that today. And I've got a question here in the chat. Does it mean that load balancer service is some kind of node port? Yeah, kind of. I mean, you may use node port, and I mean, let me say that differently. In case of on-premises, the basic flow, if you want to configure everything manually, is to expose the service using node port. And then you are, configuring your load balancer, or your firewall, or edge router, or whatever you have there, to point to that specific node ports. So this is a manual configuration in on-premise world. However, in cloud world, when you are using a load balancer, it's automatically done for you. So basically, you don't have to specify that node port. You are just specifying a load balancer, and it automatically maps a node port for you. One side note over here, because this is a cluster that runs K3S. I don't remember if I told you about that project, but it's my favorite one when it comes both for edge networking as well as creating a clusters for training purposes. As you can see, installation is super easy, and that default installation creates a couple of things for you. One of them is something called SVCLB traffic, which actually creates something that allows you to simulate the load balancers and simulate you with the services. So this is kind of magic that is happening behind the scenes here. If you are to deploy the production cluster, I highly recommend you to just spin up EKS cluster and see how it works with proper load balancers. For the sake of that CKAD group, I think it's outside of the scope, to talk a lot about cloud and load balancers. On-prem traffic provides somehow load balancer service. Yeah, that's it. Let me go to the ingress, and then we will talk about that in details. So basically, services are the one way to expose the clusters. However, there is something called ingress, which is also super useful and which automates a lot of things. So basically how ingress works. So ingress works by defining an object of type of kind ingress, and then that ingress is taken by something called ingress controller, which I will mention in a minute. And then that ingress control is basically a reverse proxy. So for example, if you are using a traffic in your cluster, this is your ingress controller, and the traffic will sit somewhere over here under routing rule, and it will basically route the traffic to the correct pod inside your cluster. So this is how it basically works. In front of that traffic, of course, you may have a cloud load balancer, or it may be just an edge router that points to your node. But the basic principle is that when using ingress controller, you are basically running a reverse proxy on every node, or maybe on just selected node, or maybe on one node. It depends on the configuration and if this is a production or development environment. But the idea here is that reverse proxy is configured by using Kubernetes. So ingresses are offering a couple of features. So for example, they provide you ability to route using a domain and paths. As you've seen before, services are only capable of routing using TCP or UDP ports. So you have no possibility to select that for that one domain. I want to route to that service, and for different domain, I want to route to the different service. So service is not capable of that, but ingress is. Ingresses additionally can terminate a TLS traffic for you. So you don't have to implement all that TLS termination inside your application. You don't have to, implement the logic of handling the certificates, then providing the certificates for the application. You can do that in the central place on the ingress. And because ingresses are kind of elastic and kind of flexible, they can act as a simple API gateways for your purposes. What is API gateway in that context? It's basically one point from the point of view of the customer of that API, of the client of that API. So your client is connecting to the single endpoint. However, you are able to split the traffic into different microservices behind the scenes. So this is API gateway pattern basically, and ingresses can act as a simple API gateway. You need to know that if you want to expose your deployments using the services in the cloud, of course, and you want to expose them as a load balancer, it will create a new load balancer for you. This is the default behavior in AWS, for example. And each load balancer costs you some money. So basically, if you've got hundreds of microservices and you were to expose them using load balancer, it will create hundreds of load balancer and cost a lot of money. But if you are using an ingress controller, it's perfectly possible to reduce that, for example, to one load balancer that will be just handling your ingress. And then using ingress controller, you are just splitting the traffic to the proper microservices. So it can greatly reduce the cost of your incoming traffic cost of the load balancer for incoming traffic. However, ingresses require something called ingress controller. As I said, it's basically kind of application that acts as a reverse proxy that you install on your cluster as some kind of add-on, but there are some downsides related to that. First, you need to install that and configure that properly. And then you need to maintain that. So by maintaining, I mean troubleshooting if there is something wrong, for example, with that ingress controller, and also update it from time to time, for example, to patch security vulnerabilities. And here's an example of ingress using virtual domain routing. So basically, we've got a client. The client is connecting to the single load balancer. And that load balancer is connecting to our ingress controller. It's not shown here. However, there is an ingress controller over here. And then there is an ingress object that actually holds the configuration for all your domains. So as you can see, we've got a couple of ingresses here, or ingress configurations. We've got first host foobark.com, and then we've got a second host called barfoo.com. And as you can see, each and every service points to the different service on the Kubernetes. So foo.com points to the service 1, and then barfoo points to the service number 2. And then, of course, service resolves that to the proper pod. And there is one thing that you need to know. Usually it's not happening like that. I mean, this is only for a conceptual thing to better understand how it works. However, let me maybe open that whiteboard and draw something. One moment, let me change that to whiteboard. Make it visible, and let's create a new one. So we've got our whiteboard. You should see that in a second. And let's add some kind of shapes over there. And let's picture the whole flow. So basically, we've got some kind of client here. Let it be a C for client. And then to show you how it works in in cloud. Let's start with the cloud. So basically what happens in the cloud? In the cloud, you've got a load balancer that is a front end for your application. This is, for example, application load balancer or network load balancer or classic load balancer in AWS. And then we've got some nodes over here. So for example, this is a node for Kubernetes. And how it works? It works like that. Node is running ingress controller. Let me put it over here. It's just a pod running on that node. And then the magic is that basically there is a service over here for ingress controller. And that service is of the type load balancer. And that specific service means, and load balancer means that it creates a load balancer over here. So basically by installing an ingress controller, you are both putting a node as well as service that creates a load balancer, external load balancer here. And what it does else, I mean, we've got that service, and that service also not only creates a load balancer, but it also exposes some kind of ports. So for example, we've got a node port here. Let me say, write it as 1, 2, 3, 4. This is, for example, a port that is external to the node, and it's actually listening on the node. So basically node is listening on port 1, 2, 3, 4. And that service is configuring a load balancer in a specific way. And by that I mean it sends the configuration here, configuration, and then load balancer is configured to point all the traffic to that specific node port. So basically there is a traffic over here. So when the customer connects to the cloud, it connects to the load balancer. Load balancer is configured to forward the traffic to a node port. And then that specific service is pointing, to the ingress controller. And what happens next? Basically, there is an ingress object over here. And the whole purpose of the ingress object is to actually configure our ingress controller. So basically it sends a configuration to the ingress controller. And ingress controller holds a registry of the whole configuration in memory. And by using that registry, it's basically containing something like application service. We've got application service over here. And then we've got some kind of pods. This is a pod 1, and then let me create a pod 2 here. And of course, we've got a proper labeling for all that services. So application service is pointing to these 2 pods. And now the magic with ingress happens. And what I mean by that? I mean, ingress controller gets the configuration from the controller and tries to configure routing of its reverse proxy. So it basically looks up here to the application service. It checks, the application service uses a couple of endpoints. This is the things I think I showed you before. Let me go and remind that quickly. So ingress controller basically looks up here to the endpoints of the service and then configures reverse proxy inside that specific ingress controller container to point directly to the pods. So basically ingress controller is routing the traffic directly to the pod. It completely skips the application service. Service here is just a service discovery locator. It's not actually used to route traffic. You may ask, why is that happening? To make the things faster. Because, if ingress controller were to connect to the service, it's basically using additional IP tables rule and it's getting slower and slower. But ingress controller is perfectly capable of connecting to the pod directly. So it saves a lot of time by resolving that things. Okay, what expose port 1, 2, 3, 4 regarding the physical things? Is it privileged pod or some host service? It's a service for ingress controller. Every service that is put here inside the Kubernetes in the cloud, because remember, we are in the cloud. So if I put another service over here, svcx type load balancer, basically now what's happening, I created an object like that, and Kube controller manager notices that there is a new object of service with the load balancer, and because Kube controller, sorry, not Kube controller, cloud controller, basically sees that there is a new service with the type load balancer, and it needs to expose that somehow using the load balancer in the cloud. So basically it examines the service, sees that, oh, we need another load balancer in front of that service. So it randomly generates a port for it, and then exposes that port on the node. So basically at that moment, the node is starting to listen on the port X, and then there is a new load balancer created in front of that service. What is box ingress shown here? What does it do? Let me go back to my presentation. Arthur says that, but Kubernetes orchestrate only pods. Nope, this is not true. Totally not true. Kubernetes orchestrates many kinds of things. Here we talked so far about pods mostly, but if you go to one of the previous meetings devoted to storage, you will see how Kubernetes is actually orchestrating the storage for you. And the same thing is happening here for the networking. So basically it not only orchestrates the pods here, but also tells nodes on which port they should listen, or maybe it tells container network interface on what rules it should apply on IP tables in order to filter the traffic between the pods. So basically Kubernetes is doing a lot of stuff, not only orchestrating the pods. Okay, let's go back to the presentation, and I will show you what's inside the ingress object. Okay, what's the difference? So ingress controller is basically some kind of pod that is running inside your cluster. I will show that in practice in a minute. Just let me go back to presentation. Okay, so we've got ingress controller. And two things about ingress and ingress controller. So ingress is an object that is built into Kubernetes, and its main purpose is to hold the configuration. But its purpose is not to serve the traffic. The traffic is served by the controller. And there are many ingress controller available, like Traffic, like Ingress Nginx, like Istio Ingress, like Ambassador. And all that controllers are doing basically the one thing. They are dynamically configured reverse proxy. So they listen on some port, take connections that are coming to the cluster, and then they are forwarding into the healthy pods. And also they may have additional services, like for example, termination of TLS, authentication and other stuff, but basically its role is to just point and handle reverse proxy functionality. And here you've got a sample ingress manifest. And as I said before, ingress is something that holds the configuration for the incoming traffic. So we've got a couple of things here. Of course, we've got some kind of API and kind for that pod. And then we've got a couple of rules. So basically, you may set some kind of host for your ingress. This will allow you to segregate the traffic based on the domain name. This field is optional. If you don't specify that, it will use just any kind of name, and will be listening for any kind of service, any kind of domain. But you may filter different domains using different rules over here. Then we've got a second part, which is basically a configuration of the path. So inside my sample Lookton Cloud domain, I can set a couple of prefixes. For example, I can set a foo and bar prefix, as you can see. And I can send different services for both of them. So for example, a foo prefix will be connected to my service 1, and then we will have a second path called bar that will connect, that will forward to the service 2 over here. And this is basically an implementation on what I showed you before, this one. Here the ingress object has a couple of rules. It's based on the host, but the same applies, for example, to the path-based routing. So you can set many different rules inside your container, inside your ingress. And this way, your traffic or your ingress nginx will read all that rules and configure the correct reverse proxy settings to match that rules. And you know, when the new request comes, it evaluates, oh, I've got a rule for that specific host, I've got a rule for that specific path prefix, so I need to route that to the specific service that I've got here in the configuration. So this is basically it. This is basically how ingress work. And there are also a couple of additional things, as I mentioned, related to the ingress itself. One thing is TLS termination. You may want to terminate all the traffic that is coming to your cluster. I mean the encrypted traffic at the edge and the edge of the cluster. And by that I mean ingress controller. It's quite simple to configure that, provided that you add a couple of additional things to your cluster. So basically, to configure TLS termination using something called cert manager, I will show that in a moment, you need to add an annotation. For example, that annotation says that we want to get a Let's Encrypt certificate from cert manager. And also, as you see, rule is the same like it was before, but we need to add another block here called TLS. And inside that TLS block, we need to set a couple of things. So first thing is we need to specify some kind of secret name. This is a secret that will be created by certificate manager, and it will save the certificate it gets from Let's Encrypt, and it will save that to that specific secret. And then we've got a second point called hosts. And here that host tells a cert manager for which domains we want that certificate to be issued. So basically, we need to make sure that in our ingress, the host here match the host here in the certificate. And this way, it will be working just fine. Sometimes you want to use, for example, a single certificate for multiple things. One of the examples is wildcard certificate. For example, if I know that I will be handling multiple domains inside my cluster, I may want to create a wildcard certificate with star.look.cloud here. And this way I can reuse the same certificate to multiple ingress objects. Yeah, and we've got two interesting projects. Basically, first one is Cert Manager. Let me maybe quickly show that for you. So Cert Manager is a tool that you can get a certificate from, a free certificate, you don't have to pay for it, for any kind of domain you own. And basically, this way you can ensure that you've got encrypted traffic for your cluster. How it works, there are two ways. You need to prove that you are owner of the domain. You can prove it in two ways. First one is to using DNS. So basically you are creating some kind of record in DNS that confirms that you own the domain. And the second one, which is especially useful in all kind of dynamic environments when you create multiple ingresses, is using HTTP validation. So basically, if your domain is pointing to the specific service in the Kubernetes, and then you can prove that you are owning the domain by telling Let's Encrypt to connect to that specific domain, and then there is some kind of challenge behind the scenes that is validated, and then the certificate is issued for you. Of course, I'm talking quickly about that because this is outside of the scope for the exam, but I think it's super nice and quite interesting project. So you may find it interesting. And there is also a second project that I find super useful. It's called external DNS. And that external DNS project is related to, well, something is, yeah, it's like. And that external project is all about configuring a DNS for you. So if you want to create a fully dynamic infrastructure in which you just, creating an ingress object and then everything is automatically configured for you, you may install both Cert Manager as well as external DNS. And this way you are specifying an ingress, and these two projects will take information from ingress like domain name, will configure the DNS for you to point to the specific load balancer, and then will issue a certificate for you. So you've got basically everything configured manually. Of course, you need to first configure that external DNS project to provide some kind of credentials, for example, I don't know, for AWS Route 53 to be able to connect and authenticate and create the proper records. But after you do so, it's almost like magic. You don't have to, do anything else. It's configured automatically. So this is it. Let me quickly see if I have anything else. Nope, basically this is it. Now it's your turn. We finished our CKAD study group. It's time for you now to schedule the exam and pass it. And if you do so, then let me know. I will be also super glad and super happy if you spend 2 or 3 minutes and just write some kind of testimonial that you liked this CKAD study group, because it will be super useful for me for promoting the next edition of that study group. If you have 5 minutes, just write 1 or 2 sentences and send it to my mail. I will be super glad for that. I will be also super glad if you send me some kind of feedback, how you liked it, what can we improve. I've got a couple of thoughts from my side to actually not follow the domain by domain approach, but topic by topic. And I think I will do another turn of that study group somewhere in the future. Yeah, and that's it. We've got a question: how exam looks like? Can we run Kubernetes documentation, Docker documentation? Yeah, you can run Kubernetes documentation. You can run Kubernetes source code. If you go to looktomcloud/YouTube, there is a recording from the first meeting. In the first meeting, I describe everything related to the exam stuff. How much it costs, how it looks like, how it's remote exam configured, what you need to prepare. So just see the first episode and recording from the first meeting. And of course, you've got also kubectl explain in the command line, so you can use that. I also highly encourage you to subscribe to the channel because I will be issuing some new videos quite soon. I've got a couple of ideas. If you have any kind of tips or things or that you would like to listen about, then just also let me know. Then I will include that in my plans. So if you have any questions, just let me know in the chat. I will wait for a minute or two. And if you have any question after that, you can just contact me using my mail you are seeing on the screen, and I try and do my best to help you. GitHub repository for self-training. Yeah. I mean, if you contact me using the Gmail, using my mail, then I will send you the examples like I did before for people that asks for that. So yes, but I will introduce the proper GitHub repository for the next training, the next edition of CKAD study group. Okay, so if you don't have any more questions, then thank you for being with me for all these meetings. I hope you like it. I hope it will help you with passing the exam, and see you soon. Bye.